The active manipulation of one's environment to suit their political or economic needs is no stranger to the human race. Much of their history has been a measure of their collective impact on Earth, only to crash into desolation with their reckless industry and warish priorities. Still, the ability to shape one's world has not been lost on the cosmic remnants of humanity, and only a few generations after discovering a new world to develop, they find themselves falling for the same godly whims and wishes. At the turn of the 2130s, Iris Corp began pumping greenhouse compounds into the atmosphere of Europa. Although this would ultimately backfire and melt the entire moon, Martian colonists took note of their rapid, albeit futile, process. By 2133, Terraformation advocates began demonstrating their support for the opening of Mars and Venus to the general populace, whereas before, humans and posthumans were naturally confined to their respective environments. No two celestial bodies in the solar system are the exact same, and so when it came to adapting a planet suitable for every race, there were a variety of unique challenges that host corporations were expected to meet. Alongside patching public genotypes to be compatible with newer climates, the general process includes warming up the object in question via greenhouse gases, re-establishing a magnetosphere to protect said gases, and introducing breathable air into the atmosphere. Even then, the results are far from Earth-like. There are often issues with temperature variation, landscaping, soil composition, and gravity. Each climate is its own challenge, but even in 2190, humanity is powerless to the enigma of gravitons, leaving every world beyond Earth in a lower state of gravity.
Europa was the first extraterrestrial body in the solar system to undergo any concentrated effort of terraformation. Unfortunately, due to a lack of foresight and caution, the excessive presence of greenhouse gases in Europa's atmosphere caused over 90% of its thick ice sheet to shatter and melt in only a few years. Once plans to simply colonize Europa's vast ocean entered the fray, terraformation efforts shifted from warming its atmosphere to warming its ocean, so they kept pumping the gas. The result was a warm inner atmosphere compressed by a weak, freezing outer shell of air, and winter clouds composed primarily of frozen water vapor hovering in between. Even with the construction of a primitive magnetic dipole to protect it from Jupiter's magnetosphere, and another to shield it from the sun, simulations showed Europa's new atmosphere to be extremely unstable, more so than Earth's moon. Continual greenhouse dispersals and hydrogen factories keep Europa's inner atmosphere warm for the time being. With a vast majority of Europa's colonies underwater, however, many of these developments have since fallen on deaf ears. Its ocean has gotten warmer and warmer with every year, to the dismay of older Safarian generations, and only a scarce few wander the surface. Efforts on Europa were something of a test run for Mars. The same overall process needed to be replicated in order to warm its surface and protect its developing atmosphere from solar radiation. The magnetic dipole needed to achieve this, however, would need to be many times larger than whatever could be done at Europa, and unlike Europa, there would be no alternative should the process backfire, not to mention the already extensive civilian presence on the Red Planet. More so than any colonized world, the terraformation of Mars is a painfully slow operation that has taken place over the course of several generations, although much more expedited than initial terraformation projections in the early 21st century. Cairo Station, constructed at the tail end of 2134, was built to divert solar winds from Mars and kickstart its atmosphere. Terrafactories in 2135 pumped carbon dioxide for nearly 50 years before Mars's average temperature reached a pristine 15 degrees Celsius. Civilian algae farms at the poles are converting the planet's vast supply of carbon dioxide into breathable air, and additional oxygen produced at terrafactories is made by oxidizing metals below the surface. It has not, however, been a particularly peaceful endeavor. The tremendous air currents produced by the melting of Mars's polar caps wrought several seasons of intense dust storms that ravaged most of the surface, which, notably, had been expected by the host corporations involved. The algae used to produce oxygen on Mars tends to thrive much more than it should in the low-competition, high carbon dioxide environment, and some farms have even been overrun by these red vines. There are also bureaucratic entanglements involved with these dispersals, and some sectors receive much more attention than others based on economic incentives alone. Terrafactories came to a close at the turn of the 2190s as the finishing touches on Mars's climate come into effect. Projections show the planet will be fully Earth-like, or the closest it can be, by 2230.
An executive from Terraform was once asked what he thought of ongoing efforts to terraform Venus. Infamously, he replied, "Hell of a good time." To outsiders, this may appear bullheaded or even irreverent. But in all truth, it's difficult for anyone involved with the terraformation of Venus to not laud its explosive, reckless nature. It is, after all, the most infamously chaotic terraformation of a planet thus far. Venus itself was a hellish waste of volcanoes and crushing skies, with a runaway greenhouse effect and the hottest average temperature of any planet in the solar system. But, like Mars, advocates push to rid the planet of these toxic qualities and open it to the cosmic community. This presented a unique challenge to the host corporations involved at Venus. Whereas simply adding greenhouse gases to the atmosphere seemed to kill two birds with one stone, Venus demanded the active removal of its atmosphere in order to cool down its surface and weaken its atmospheric pressure. And the issue with that was no one knew exactly how to remove atmosphere. Pumping it off-world would take too much time and resources to pull off, so host corporations began looking into compounds that would react and cancel out the Venusian atmosphere. Ocean 4, in partnership with Mirarel, looked into microbes that could float in Venus's clouds and produce photosynthesis, shrinking the planet's dense CO2 composition. But this also ran into a dead end when projections showed Venus's total oxygenation by 2400 AD. Eventually, these corporations went with another idea. Rather than wait for microbes to eat away at the CO2, or for the CO2 to be shipped off-world, they would literally bombard the planet with massive payloads of hydrogen, producing water and graphite. Although misleading in name, these hydrogen bombs began their runs in 2142, the official start of what humanity has dubbed the Venus Wars, and dispersals continue today. These runs range from small pops in the upper atmosphere to full-out bomber routes, complete with large and dazzling explosions that litter the Venusian sky. Given its size, the Venus Wars are expected to continue for at least another 50 years, and the first pockets of N2 and O2 have just begun to emerge from primitive terrafactories in major city centers. Still, while Mars, Europa, and Titan are largely Earth-like in their current state, Venus has a long way to go if it wants to show up its sister planets. Titan's astronomical distance from Mars and the Sun was a challenge in and of itself for its first colonists and host corporations. To terraform it into a stable, Earth-like environment was near impossible. Although Saturn's low radiation and distance from the Sun gave Titan a better chance than Europa or Mars did when it came to keeping its atmosphere, any concentrated effort to transport civilians or resources to Titan would be far too unwieldy for host corporations in the 2130s. It was only 2 decades later, with a larger and more exploitable market, that plans for Titan were finally set in motion. Titan's atmosphere was already nitrogen-based, which seemed encouraging. But there was an issue. Almost all greenhouse gases used to warm planet thus far could not be used on Titan. It was simply too cold and too far from the Sun to process CO2 in a way that remained gaseous. Thermonuclear devices were too destructive, orbital mirrors were too costly, and to top it off, adding gas to such an atmosphere and heating up the planet would almost certainly lead to a runaway greenhouse effect. The answer came to them when trace elements of fluorine, given off by Starship engines, began reacting with Titan's nitrogen-rich atmosphere, producing an extremely potent greenhouse compound, nitrogen trifluoride. Normally, NF3 would turn to liquid at Titan's aerial temperature, but heat residue from those same engines keeps fluorine warm enough to react with nitrogen and form an incredibly strong greenhouse gas. By populating Titan's skies with starships, host corporations were able to simultaneously heat up the moon and construct a network of interconnected aerial colonies. When Titan's average temperature reached approximately negative 65 degrees Celsius, emissions shifted to the greenhouse compound sulfur hexafluoride, a gas with a stronger greenhouse potential than NF3. CO2 was a promising choice, but given Titan's distance, SF6 was much more readily available. By 2170, Titan had reached an average temperature of 0 degrees Celsius, and today it is still rising. Oxygen is still being pumped into Titan's atmosphere, so for the time being, native avian colonists have to survive using conventional air supplies.